Hello everyone. How are you all? Yesterday we had discussed about the first chemical property of metals and non-metals. Before that we have studied all the physical properties of metals and non-metals. Yes students, let's recall yesterday's topic first. Yesterday we had discussed about the formation of ions. About ions you have studied in your previous class also. 7th in the chapter elements and compounds. Yes, in that chapter you have studied a basic introduction about atomic number, elements, compounds, ions and valencies. Yes students, in that chapter ions, yesterday we had taken an example of sodium. In that sodium we had shown that sodium is having 1 plus charge. Ions, now by taking the example of sodium, let me explain you what are ions again. Yes students, ions is the whatever the atoms left in the outermost shell to which an element wants to give to someone. That is a positive ion. And if the number of atoms is more than 4, then an element wants to take some electron from other element to complete its outermost shell. Just remember one thing whenever you are studying anything related to elements, that elements want to make themselves stable, and when this wish will get complete, when they feel stable or settle, yes, when their outermost shell is complete. See students, atom, outside the atoms there are number of orbitals, or we can say shells. Electrons are lying in that shells, are revolving around the element, around the nucleus. Nucleus is in the center, in which an element is having proton and neutron, and in the orbitals electrons are gathered, are revolving. In the first orbital the maximum number of electrons is 2. And in the second orbital, the maximum number of electrons will be 8. In the next one, 8 also. So, if the element, just take an example of sodium over here again. See, sodium is having an atomic number of 10. The division of 11. The division of 11 is 2 in the first orbital, 8 in the next orbital, and in the last orbital sodium is having only 1 electron. To make itself stable, sodium want to give that 1 electron to someone. That's why sodium is having a charge of giving the electron, that is a positive. And that giving of 1 electron is the 1 ion of sodium. Sodium is a metal, and most of the metals have a property to give the electrons, to lose electrons. That's why metals are having positive charge. They are having positive ions. We had discussed 3 examples yesterday: sodium, aluminium and oxygen. You can take and many more examples. You can discuss about lithium. You can discuss about calcium, magnesium. Yes students, to do the practice of these learning of ions, you can take the atomic number of different elements and find out how many electrons are left in the outermost shell. And that left electrons, just decide if they are having 1, 2 or 3 electrons. Then it means that particular element will lose then that 3 electrons. And if the electron is having 5, 6, 7 electrons in the outermost shell, then to complete its outermost shell, that element must take the electrons from someone. This is the main situation. Now carbon. Carbon is having an atomic number of 6. The breaking of atomic number, that is electronic configuration of carbon, is 2, 4. It means 2 in the first orbital, 4 in the next orbital. Means the carbon needs to take 4 electrons from someone. It is very difficult. That's why carbon neither take nor giving the electrons. Carbon used to share the electrons with someone. But as we had discussed the atomic number of oxygen, oxygen is having 8 electrons. The breaking is 2, 6. 6 in the outermost shell. Now oxygen needs 2 electrons to complete its outermost shell. That 2 electrons it can take from someone, from anyone. That is to make itself stable. So the basic needs for any of the element is to stable itself by giving or by taking the electron. If that particular element is taking the electron, then it receive negative charge, and if it is giving the electron, then it receive a positive charge. Isn't it? I think formation of ions is clear to you. As I am recalling this topic, this is the previous class topic. Few of you definitely knows about it. And if you forget, you can read this particular topic from your previous class book. Okay, students? Now come to the point, come to the next chemical properties. Let's begin with the reactivity of metals. Yes, students. Metals have a particular reactivity. Whether they are highly reactive or less reactive. Generally, metals are reactive. That's why mostly occur in the combined state in nature as minerals. Yes, students, are we able to find out a particular piece of metal in the soil? No, because metals are not found in the nature separately. They are present in the atmosphere, or we can say in the soil, in the form of some compounds. That compounds are known as minerals. Yes, students, like iron is present in the form of iron oxide, calcium oxide, magnesium oxide, etc. These all are the examples that metals are not present in the atmosphere separately. If we want a particular metal, or we have to separate that metal, or we can say we have to extract that metal from its ores. These compounds in which these metals are present are known as ores. O-R-E-S, ores. Okay, students? Now, metals react with air and water. Yes, students. Metals are reactive with air and water. You have already studied about the corrosion of iron in the previous class, in which you have studied that iron reacts with water, with air in the presence of moisture. It means iron was reacting with air and water. But that process is not an instant process. If we are using iron grills, iron doors at our home, but it doesn't happen that right now I am taking one iron product and tomorrow I found that product is corroded. No, it doesn't happen, because the reaction is slow and it takes a lot of time. Maybe after 1 or 2 years that iron will become corroded. It means that is a slow reaction. Now, if sodium left in open immediately combines with oxygen. Yes, students, have you ever seen any magic show? Many times magicians used to show a magic in which they break a coconut, and in that coconut fire is blowing out. Yes, and people feel very thrilled and excited. But the problem is there, they won't know the reason behind it. That magician insert the sodium inside the coconut, and removing out all the water which is present inside the coconut. And when that person break the coconut, then fire start blowing out. Reason is that sodium comes directly in contact with oxygen and reacts spontaneously. Yes, students, sodium is this much reactive that you don't need to do anything. Sodium itself reacts with oxygen if it comes in contact. Similarly, same case is with potassium. Potassium is also highly reactive if it comes in contact with oxygen, then it reacts spontaneously. We don't need to do anything. That's why we found sodium and potassium always in a compound form. If we got the single element, single metal, only sodium, then it will be difficult for us to maintain the security, to maintain the reaction between sodium and air. Yes, it means these are highly reactive. Now the next one is magnesium. I think everyone have burned cracker. Yes, when we burn a cracker, then what will happen? We have to ignite it. We have to provide some fire to that cracker. Then only that fire will burn or burst. That fire needs by the magnesium which is present in the cracker, and then after that magnesium will ignite it, it burns with a sparkling fire that we enjoy a lot. Yes, students, it means magnesium is less reactive than sodium, but still it is highly reactive in itself. Okay, after that, iron and copper. We are using these two metals in our day-to-day life. Iron is present at different places in our home. Copper, we are using copper utensils, copper wiring, etc. As they are less reactive, that's why we can maintain these things. These things needs less maintenance. We can use them if we are performing the paint or lubrication on the upper surface and protecting it with contact of air and water. If we are applying paint and lubrication means oil and grease on the upper surface of these metals, we can prevent them from rusting. Yes, it means metals have different reactivity. As you understand over here that sodium, potassium are having different reactivity. Similarly, magnesium, iron is having different reactivity. Copper is even less reactive than iron. And after that, you have seen gold, silver at your home. Are they reactive like them? No, they are very less reactive, or we can say non-reactive, as they won't harm us. If they will react, then what will happen? We are unable to use them as jewelry purpose. We are unable to touch them, okay students, frequently, because we are not touching reactive metals frequently. Okay, please don't consider it that we are touching iron and copper. Yes, we are touching them because they are also less reactive, but when they are corroded, they are also poisonous. If we are using them, if we are taking any of such product inside our body, then definitely they will harm us. Okay students, now some metals are highly reactive and some are less, as we got the examples also. Highly reactive, sodium, potassium, magnesium, calcium, and less reactive, gold, silver, platinum, etc. Metals are arranged in a series called reactivity series according to their reactivity. See, reactivity of metals depend on the ease with which its atom can lose the electron, valence electron, easily. It will react rapidly with other substances and hence it is known as reactive metals. Students, how we can define that a particular element, particular metal is reactive or not? See, as Again, we are taking the example of sodium. See, students, sodium is having only one electron in its outermost shell. It means it is easy for sodium to lose one electron. And after losing that electron, the sodium will become stable. The tendency of becoming stable early as possible makes a particular metal more reactive. If that particular metal is having more electrons in its outermost shell, then what will happen? It is difficult for that metal to settle with someone. That's why the easiest, less complex situation will make a particular metal more reactive. In the case of the elements, in the case of the metals are having more electrons, what will happen? They will take time to combine with someone, or they have to lose more electrons. That's why they are less reactive. Sodium and potassium are highly reactive because sodium is having one electron in its outermost shell. The atomic number of sodium is 11 and the breaking is 281. And the potassium is having the atomic number of 19. And the breaking means electronic configuration is first orbital 2 electrons, second 8, third 8 and the fourth one only 1 electron. Okay, that's why they both have to lose only 1 electron and they are highly reactive. And the next most reactive, lesser than sodium and potassium, but in itself they are highly reactive, that is calcium and magnesium. Yes, these electrons have to lose 2 electrons from their outermost shell because magnesium, the atomic number of magnesium is 12. First orbital 2 electrons, second 8 and the third last orbital having 2 electrons. Similarly, calcium is having 20 atomic number. Again, you are able to write the electronic configuration of calcium, and calcium also have 2 electrons in its outermost shell. That's why it is less reactive than sodium and potassium, but in itself they are highly reactive. Then the next thing is aluminium 3+, 13 atomic number, 283 is the breaking. Okay students, etc. and etc. Many more examples are there, but it is clear that atoms have a power to lose the electrons. Now one more thing I have to explain, that the number of electrons which is present in the outermost shell is the valence electrons. Okay, valency, and the atoms electrons which a particular element is losing or gaining is the ions. Again I am telling you, see students, if the formation of ions is clear to you, then you can easily understand all the chemical properties. And if you have problem in that chemical property, then it will be difficult for you to understand it. Okay, now the next thing is reactivity series. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. Yes, reactivity of metals in decreasing order means highly reactive elements are lying at the top and less reactive, rare, non-reactive metals are at the bottom. Okay, now this is a trick to learn the reactivity series. Please stop calling me a careless zebra. Instead, trying to learn how copper and mercury save gold and platinum. See, this is a trick to learn, to cram the reactivity series that you have to learn. Please, P stands for potassium, S stands for sodium, C stands for calcium, M stands for magnesium, A for aluminium, C for carbon, Z for zinc, I for iron, T for tin, L for lead, H for hydrogen, copper, mercury, S for silver, gold and platinum. Okay, this is the series in decreasing order. Okay, now one more thing I have to tell you, that we are including two non-metals over here, that is carbon and hydrogen. Why we are including these two in the series of metals? See students, carbon and hydrogen are the most needful non-metals. Reason is that these non-metals, these elements are very useful in the extraction of metals. Extraction means separating the metals from its ore. That's why we have to know the reactivity of these two non-metals, so that we will understand that carbon and hydrogen can react with which metal. Okay students, that's why we are including these two non-metals in this series.